In Mod 2A, we are going to look at factoring. The greatest common factor, which is abbreviated GCF, of two terms is the largest factor that divides both terms. Remember, a factor is something that you can multiply by another item to equal the number you are looking at. We are being asked to find the greatest common factor for 15x squared and 25c to the fourth. When you are looking at items like this and you want to find the greatest common factor, look at each individual item. For example, let's just look at the 15. The factors of 15 are 1, 3, 5, and 15. The factors of 25 are 1, 5, and 25. Each of those terms had a variable on them, but the variables are different, so we don't need to consider those at all. Looking at the list of factors for each of those numbers, there is only one factor that's in common, so the GCF here is that one factor, which is 5. On our second example, we have 5a to the fourth and 4m squared. The factors of 5 are 1 and 5. The factors of 4 are 1, 2, and 4. The letters are completely different, so we don't need to consider those. So in looking at the GCF, the only thing that they have in common is the 1. On our next example, we have the terms of 7x cubed v to the 7th x to the 8th and 14w to the 6th x squared. For 7, let's just look at the numbers first. The factors are only 1 and 7. For 14, the factors are 1, 2, 7, and 14. So for our GCF, the largest factor that's in common is the 7. In looking at the letters, there is an X in both of these individual terms. When you have matching letters, your greatest common factor is the smallest power of those. So our common letter of X, we use the smallest power, which is the squared. On our last example for GCF, we have 12w to the fourth and 15u to the sixth w to the eighth v squared. Let's start by looking at the numbers for 12. The factors are 1, 2, 3, 4, 6, and 12. For 15, the factors are 1, 3, 5, and 15. What is the only factor they have in common besides 1 is the 3. So our GCF for the number part is 3. Looking at the letters, we have a W in both terms and a V in both terms. Remember that we take the smallest power of the letters. So it's going to be W to the first and V to the second. The next thing we're going to do is look at factoring out common factors in a binomial. And when you do this, you look for the GCF of the terms of this binomial. Your directions will simply be to factor. When it says factor, you look for the common term in both of these. 21 and 14 both divide by 7. So we're going to take 7 and pull it out to the front. Now, inside the set of parentheses, we're going to be writing down what would be left if we took each of those items divided by 7. 21 divided by 7 leaves us 3. Plus 14w divided by 7 leaves us 2w. On our second example, we have the binomial, two terms, of 6y plus 18. When you look at those, 6 goes into both items. So we're going to pull 6 out to the front. If we take 6y divided by 6, 6 divided by 6 is 1. So we would have 1 left as our number, and the y would still be there. Plus 18 divided by 6 is 3. It's not necessary to write the 1 in front of the y, so you can just write 6 times y plus 3. For our next example, we have 4y plus 10y to the third. The GCF of 4 and 10 is 2. So we're going to take out a 2. There is a y in both terms. So we take out the lowest power, which is the y to the first. If you take 4y divided by 2y, what's left is 2. If you take 10y to the third divided by 2y, what's left is 5, and then subtract your powers, y squared. On our last example with binomials, we have 12m squared minus 15m to the third. The GCF of 12 and 15 is 3. Take out the smallest power on those matching letters, so we're going to take out a squared. 12m squared divided by 3m squared leaves us with 4, minus 15m to the third divided by 3m squared leaves us with 5m. We're going to be looking at factoring by grouping. When you are doing factoring by grouping, the first thing you have to look for is, do you have 4 terms? If you have 4 terms, you're going to split those in half, 2 groups of 2 terms each. You're going to find the GCF for each of the pairs of terms, and then find the GCF of that result. Our first example of factoring by grouping, we first want to look and see, do we have 4 terms? Yes, we do. So the first thing we're going to do is split those terms in half. Now, we're going to take out the common factor in each of the pairs of terms. So in looking at x cubed plus 3x squared, what's the GCF? X squared is the GCF. If I take x cubed divided by x squared, I will have x left. If I take 3x squared divided by x squared, I will have plus 3 left. Now look at the second pair of terms, 7x and 21. What's in common with those 2 terms? A 7 is in common. So we're going to take out a 7. If we take 7x divided by 7, the x is left. And if we take 21 divided by 7, there is a 3 left. So what you need to notice is that there is a common factor now of x plus 3. That should happen when you're doing factoring by grouping. So now we're going to do the same thing that we've been doing. We're going to take out that common factor of x plus 3. What's left if I take x plus 3 out of the whole first term of x squared times x plus 3? What's left is the x squared. What happens if I take the x plus 3 out of the term of 7 times x plus 3? What's left is the 7. And so now we have factored that original expression. In looking at our next example, we have 4 terms, so the first thing we're going to do is split it in half and look at it 2 terms at a time. On the first 2 terms of u cubed minus 2u squared, what's in common? U squared. If I take u cubed divided by u squared, there's a u left. Take negative 2u squared divided by u squared, what's left is negative 2. Now move on to the second pair. We have 5u and 10. What's in common for those two is the 5. So we're going to take out a positive 5. If I take 5u divided by 5, what's left is u. Negative 10 divided by 5 leaves minus 2. Did we get a matching quantity like we did in the last problem? Yes, we did. So now that is our GCF. We're going to take it out front. And what's left, if we take u minus 2 out of the first term, is the u squared. What's left if we take u minus 2 out of the second term is plus 5. We're going to start looking at factoring trinomials. Remember, trinomial means 3 terms. When you are factoring trinomials, it's important to first check and see, do you have any common factors among all 3 terms? If you don't, and the leading coefficient, that means the number in front of the squared term, is 1, we're going to look for factors of the third term that would either add or subtract to create the second term. Your directions will tell you to factor completely. When the directions say that, that means that if there are common terms, you have to have factored that out before you completed your answer. The first item that we are going to factor is y squared plus 5y minus 14. There are no common factors, so I know that when I factor this, it's going to have to break into 2 sets of parentheses, and since I have a y squared, I have to have a y in the beginning of each one. My last term is negative 14, and I want to think about what factors of negative 14 would add or subtract to equal positive 5. If you think about 14, the factors are 2 and 7. But we need it to be negative 14. So should it be a positive 7 or a negative 7? Well, if I have positive 7 and negative 2, that will give me the positive 5 that I need. So this factors into y plus 7 times y minus 2. On our second one, we have x squared minus 8x plus 15. So we know that we have to have an x in the front of each one of these. Remember that when your middle sign only is negative, both of your factors will have a negative in them. Now, what can you think of that multiplies to equal 15 and would combine to equal 8? The factors of 15 that would work together to give us 8 are 3 and 5. So we're going to have minus 3 and minus 5. Note that you could write that the other direction, the 5 in the first parentheses and the 3 in the second parentheses, because both of them are negative. On our next example, we have 4w squared minus 28w plus 24. Notice that we have a 4 out in front of that squared term. So check and see, does 4 go into all of those numbers? And it does. So the first thing we have to do is factor out that 4. If I take 4w squared divided by 4, I'm going to have w squared. If I take negative 28w divided by 4, I'm going to have negative 7w. And then if I take 24 divided by 4, I'm going to have 6. Now look at what's left inside and see if that factors. So we know we've got a w squared. We have to have a w in each one. Find factors of 6 that will combine to equal 7 with both of the signs being negative because the middle term only is negative. Well, 6 and 1 will combine to equal 7. So we're going to have w minus 6 and w minus 1. On our next one, we again have a coefficient in front of the x squared that is a common factor. So we're going to take out that 5. it will leave us with x squared. 40 divided by 5 gives us 8x, and then the 100 divided by 5, we're going to have minus 20. So now break down the trinomial that's left inside. We know we have to have an x in the beginning. Our last term is negative 20. So we need to think of factors of 20 that would combine somehow, adding or subtracting, to give us 8. That is 10 and 2. One of those has to be negative. The bigger factor has to match the sign of the middle term. The bigger factor is the 10. The middle term is negative. So we're going to do minus 10 and plus 2. On the next one, we have w squared plus 14w plus 49. We do not have a coefficient in front, so we know that we have to have a w in each one. Because that whole trinomial is positive, we know that our signs will both be positive. What multiplies to equal 49 and adds or subtracts? In this case, it would be adding because the signs are the same. What multiplies to equal 49 and adds to equal 14? Well, that's 7 and 7. We're going to look at a technique that will always work for factoring trinomials. We're going to use it because our next problems will have a leading coefficient other than 1, and those are a little harder. We're going to use what's called the AC method. Remember, this works on any trinomial that you are factoring. To use this method, you take the leading coefficient, which is the A, times the constant, the plain number, which is the C. Then you find the factors of this result that would be able to add or subtract to equal the B. You're going to rewrite the trinomial, creating the two terms that have those factors. Now you have a problem that is factoring by grouping. Beware, if you do have a negative sign on the first term, on the squared term, factor out a -1 before you start the AC method. We are going to factor 7x squared minus 15x plus 8 by using this new AC method. First, we're going to look at what A times C equals. Our A is 7. Our C is 8. 7 times 8 is 56. Now ask yourself, what multiplies to equal 56 and would add or subtract to equal 15? Well, that is the 7 and the 8. So we are going to change our negative 15x into negative 7x and negative 8x. We're going to split that middle term into those two terms. The problem now becomes 7x squared minus 7x minus 8x plus 8. This new polynomial is equal to the original trinomial. It just looks different because we switched the negative 15x and split it to become negative 7 and negative 8. One thing I want you to note is that I put the negative 7x term first. I did that because my first term also has 7 and x in it. I want the items next to each other that will have common factors. By putting the negative 8x second, I put it next to the last term, which also has an 8 in it, so I have common factors. Now I'm going to split this in half and do factor by grouping. So what's in common on the first two terms? 7x. If I take 7x out of the first term, what's left is x. Take negative 7x divided by 7x, I get -1. What's in common on the second two terms is an 8. But kind of look ahead. If I just take out a positive 8, I would have negative x and positive 1. That's not going to work. I'm going to take out a negative 8 instead. Negative 8x divided by negative 8 gives me positive x, and then positive 8 divided by negative 8 leaves me with negative 1. That way I made sure that my two quantities will match each other. Factor out those like quantities of x minus 1. If you take x minus 1 out of this whole first term, what's left is 7x. If you take it out of the whole second term, what's left is minus 8. On the problem 3x squared plus 16x plus 20, start by doing your a times c. We're going to take 3 times 20 and get 60. Now we want to look for something that multiplies to equal 60 and would add or subtract to equal 16. That would be 10 times 6. So we are going to use 10x and 6x. And since our 16x is positive, both of these factors will be positive. Look at your first term. See that it's 3x squared. Of the terms 10x and 6x, 6x has something in common with 3x squared. So when I rewrite my problem, I'm going to put the 6x next to the 3x. And then I'm going to put the 10x next to the 20. And that works out well also because 10 and 20 have a common factor. We are going to split this in half and look for common factors in each half. Take 3x out of the first two terms. 3x squared divided by 3x leaves me with x. 6x divided by 3x leaves me with 2. In the next two terms, both are positive. What's in common with 10 and 20? 10. We're going to take that out. 10x divided by 10 leaves me with x. 20 divided by 10 leaves me with 2. Did we get matching quantities? Yes. So now, take out the matching quantity, and what's left from the first term is 3x. What's left from the second term is plus 10. What's different about this next one is that our third term is negative. So we're going to have to use that and take that into account as we work on this. A times c is going to be 2 times negative 24, which gives us negative 48. Now we have to ask ourselves what multiplies to equal negative 48 and then would somehow add or subtract to equal 13. That might be a harder one for you to come up with, but it's 16 and 3. 16 times 3 is 48, and if we subtract 16 and 3, we will get 13. Keep in mind that we need to get a positive 13, and our factors have to be one positive and one negative. The bigger factor needs to match the sign of that middle term. So we are going to use positive 16z and negative 3z. When I start rewriting as 4 terms, I'm going to have my first term, and then I'm going to look at the 2 terms I said I was going to use, 16z and negative 3z. The 16 has something in common with the 2, so I'm going to put plus 16z next. Then I'm going to write the negative 3z and negative 24. We're now going to split in half. And if you look at those first 2 terms, 2 and z is in common. 2z squared divided by 2z is z. 16z divided by 2z gives me plus 8. When we look at the second pair, negative 3z and negative 24 have a negative 3 in common. Negative 3z divided by negative 3 gives me positive z. Negative 24 divided by negative 3 gives me positive 8. Did we get our matching quantities? Yes, we did. So factor out the matching quantity. And then what's left from the first term is the 2z. What's left from the second term is the minus 3. On this last problem, our first term is negative. So the first thing that we have to do is factor out a negative 1. When we do that, remember that the effect it will have is changing the signs of each term inside. So now we have positive 2x squared, positive 9x, and positive 10. When we do our AC method, we do it on what's inside the parentheses. We're going to take 2 times 10 and get 20. What multiplies to equal 20 and would add or subtract to equal 9? That would be 5x and 4x. When we start our rewrite, we have to keep that negative 1 out on the very front. Now, because I'm going to have a bunch of terms in here, I'm going to use a bracket just to change up my grouping symbol a little bit. We're going to keep the 2x squared. Looking at the two terms, we said we were going to use 5x and 4x. 4x has something in common with the 2x squared, so we're going to put 4x next. Then we're going to continue on with the 5x, and then the last term inside is plus 10. We're going to split those 4 terms inside in half. We still have to keep that negative 1 on the very front. Now, looking at the first 2 terms, 2x squared and 4x, 2x is in common. 2x squared divided by 2x is x. 4x divided by 2x is plus 2. On the second pair of terms, what's in common with 5x and 10 is a 5. 5x divided by 5 is x. 10 divided by 5 is 2. Do we have matching quantities? Yes. Again, keep that negative 1 on the front and now work on the inside of the brackets. Take that matching quantity of x plus 2 out front. What's left from the first term is the 2x. What's left from the second term is the plus 5. The last kind of problem we're going to look at in factoring is difference of squares. Remember that the word difference means subtraction. So what you have to have when you have difference of squares is 2 terms with subtraction between them, and both terms need to be squares. When you look at our first problem, y squared minus 16, are they both squares? Yes. Is it 2 terms with subtraction between them? Yes. These kinds of problems always factor using the square root of each term. The square root of y squared is y. The square root of 16 is 4. The signs are 1 positive and 1 negative. On the second one, we have 2 terms. Subtraction between them. Both are squares. The square root of 81 is 9. The square root of 4y squared is 2y. One's positive, one's negative. I tend to write plus first, minus second, but you can write it either way. On the third one, are they both squares? Yes. Is it subtraction? Yes. So, square root of 100x squared is 10x. The square root of 49 is 7, so I'll do it the other way this time, minus 7 plus 7. Do be careful when you see one like D. You have to notice that there's a common factor there. Both of those terms divide by 4. So we're going to take out 4, and both terms have a z in them. Take out the smaller power, z squared. 4z to the 4th divided by 4z squared leaves z squared minus 16z squared divided by 4z squared is 4. Look at what's left in your parentheses. That is still a difference of squares. So we're going to break it into the square root of z squared is z, square root of 4 is 2, and we're going to have one positive, one negative.